Okay, hello again for the part 6 of April's exam preparation course or series of videos. So far we have solved more than 120 questions and we have almost 20 to 25 left. And after finishing all those 6 videos, that should be enough to prepare you for the CCNA 20301 exam and to make you able to take it and pass it surely. And of course that will be after you finish the complete course, whether you have studied by yourself from the cert guide or from the course, the English course that's available on the channel, and also after finishing this series of preparation. Yesterday I have published another video which is of how to take the exam from your home, because starting from April 15 2020 and so on, Cisco will allow for any candidate to take their exams, most of their exams from home by installing some proctored and protected application from Pearson View, and those Pearson View guys will guide you through all the way to prepare yourself and to acquire the exam questions, answer them, and let the applications correct the questions and give you the score, and that's it. It will be a complete emulation for the same environment and the same experience of the exam that was taken before in the exam centers. Okay, there is another video, so it will be available. You can see it in the channel. So it's the latest video of how to take the CCNA exam from home. Okay, and for the preparation, let's start with the first question today, which is question 126. Okay, that would be refer to the exhibit, which is this picture, which statement about the interface that generated the output is true. Okay, according to this exhibit, I can see that port security is enabled. So this exhibit is about port security. Okay, the status secure up. The violation is shut down. This is the default guy, which gives an error disable and shut down the interface. Aging time is not specified. The maximum MAC addresses allowed are only 5. The sixth one will cause a shutdown and error disabled. The total MAC addresses currently learned are 1, which is configured manually and written by hand, no sticky at all, and that's it. No violation count so far. So one of these answers should be correct. 5 secure MAC addresses are dynamically learned on this interface. No. Number 5 is about the maximum allowed MAC addresses, whether they were MAC, sticky, manual. In all of the cases, the maximum should be only 5. A syslog message is generated when a validation occurs. In the shutdown syslog message, yes, there will be a syslog message of. Okay, thank you. I've just received that the Assassin's Creed is up. Okay, it has been a free offer of Ubisoft. Thanks a lot. Okay. A syslog message is generated when a violation occurs. Yes, a violation will. Sorry, a Cisco message probably would occur with the violation, because it will occur with the protect. I'm sorry, status. When there is a protect violation mode, this will generate this syslog message, but I'm not sure about the violation, about the shutdown. Let's check CND before going back to B. The one source MAC address is manually configured on the interface. Yes, currently one manually configured MAC address is there, so this definitely is correct. This one is probably not, so I will delete it. One secure MAC address is dynamically configured on the interface. No, because you can see no sticky and no total other than the configure, so definitely there is no dynamically MAC address learned. So C would be correct for this question. Good. 127. Refer to the exhibit, and the exhibit is about 3 routers, meaning 4 broadcast domains. This one, this one, this one, and this one, connected to PCs or connecting to PCs. When PC1 sends a packet to PC2, okay, packet has a source and destination IP address. When it arrives on, I'm sorry. Oh, I'm sorry. Yeah, that would be good. Okay. So the question again says that refer to the exhibit. When PC1 sends a packet to PC2, the packet has which source and destination IP address when it arrives at gigabit Ethernet 00 of R2? Okay, before diving into this question, there is 2 different behaviors about frames and packets. while they are traveling along the way. And these are extremely important for you to know for exams, troubleshooting, and working in the environments. Okay, so we have a frame and we have a packet, and actually the packet is encapsulated inside the frame, so the frame is bigger. It looks this way. This is the big frame and this is a smaller packet inside it. We can check it this way. The idea is that what does the frame contains majorly some data and the destination MAC address, MAC, and the source MAC address. Okay, this is the most important thing about the frame, and the most important thing about one of the most important things about a packet that it contains in its field a destination IP address and the destination MAC address. A source IP address. I'm definitely sorry over that. Okay. So a frame contains source and destination MAC. A packet contains source and destination IP. What's the difference right now? The difference is actually who is the destination and the source, because it will differ based on the datagram, whether it was a frame or packet. Okay. Imagine that we have a packet that will be sent from PC number 1 all the way to PC number 2. What will happen is the PC will send a frame that contains inside it a packet. Okay, so you are sure right now that both frames and packets will be sent out PC1 to PC2. The point is, the moral of the story, or the major things that you need to focus on, believe and trust, is when a PC sends a packet. Okay, so there is a frame anyway. There is a frame that is encapsulating this packet inside it. But when a PC sends a packet out of itself, as it is the source, to destination, which is PC2, the source IP address of this packet will be me, the IP address of this PC, and the destination the destination IP address inside this packet field will be the IP address of the destination, the final destination that I want to reach. So the source IP address will be the IP address of PC1. Okay, the destination IP address will be IP address of PC2. We need to agree on that. Okay, this is for packet. This is the simple thing, and that will stay that will stay fixed, not changed all the way. So the packet will travels to this guy, a 60 million router in the way, whatever. It's carrying a source IP address of PC1 and the destination IP address of PC2. That's it. So the point is for the frame, because the frame contains the packet inside it. Okay, for this frame, for this frame, there is a source and destination MAC address. This thing is interchangeable. Okay, this one changes per hop. This one changes per broadcast domain, because so the frame source and destination MAC address, the frame source and destination MAC address will keep changing all the way. The source and destination IP address are fixed, never changing, but the source and destination frame, which are fields here inside the frame, which are shown like in this place, destination MAC and source MAC, those will keep changing all the way. So once the packet travels out of here, a frame will be sent. This frame is containing a packet saying that the source IP is PC1, the destination IP is PC2. But for the frame that just went out of PC1, the source MAC address will be the MAC address of this PC. The destination MAC address will be the MAC address of port gigabit 00. Okay, or the destination MAC address of the router, this router, the system MAC address of this router. Once the frames hit here, it will rechange itself again to be sent out to R2. What will happen is that the frame will make its source MAC address the MAC address of this router, and the destination MAC address will be the MAC address of R2. Okay, so this is for the pixel. So it changed both the source and destination MAC address. The destination MAC address of the old frame is now the source MAC address of this new frame, because it will go out of R1 to R2, and the destination MAC address will be the MAC address of R2. But for the packet that's encapsulated inside this frame, it will stay the same. It's fixed. It has the same source and IP destination. Okay, source and destination IP address, I'm sorry, the same thing. Once the frame reaches R2, it will also change again its source and destination. MAC, the source will be R2's MAC, the destination will be R3's MAC address, but the packets are still having the same information, not changed. Once this frame is reach R3 and wants to go to its final destination, which is the IP address of PC2, based on the ARP and other informations, this IP address is on this interface, so the frame will change its information, making R3 the source MAC, PC2 the destination MAC, but the packet still having the same source and destination IP address, and will go finally to PC2. So this is what's happening for the frame and the IP address inside it. The packet, I'm sorry, inside it. The packet is fixed all the way, but the frame will keep changing its source and destination IP address all the way until it reaches the desired destination. So why I mentioned all of that, because the question says when PC1 sends a packet to PC2, now we know the packet from PC1 to PC2 will always contain the same source and destination IP address. Okay, so the question says which source and destination IP address when it arrives on gigabit Ethernet 00 on R2, the same thing. It should be the same thing. Okay, so that will be the source will be of this PC, which is 192.168.10.10. Okay, and the destination should be 192.168.20.10. Okay, so the source should be 10.10, correct, but the destination should be 20.10. No, not this one. The source will be 20. No, definitely not. The source will be 10.10 and the destination will be 20.10. That's definitely correct. The source will be 10, 10, 10. No, all of them are incorrect. Okay, so the source will be the IP address of PC1. The destination will be IP address of PC2. So no matter the gigabit interface, the router, the hop, whatever, the packet is fixed, containing the same source and destination IP address, but the frame will keep changing every time. Okay, so C will be the correct answer. Okay, 128. Refer to the exhibit. There should be a dot here. Okay, or whatever. The exhibit is about this router connected to a switch with two PCs, so he is their gateway. This router is also the same. There is a connection between the routers. Users in your office are complaining that they cannot connect to the servers at the remote site. So these two guys are not able to reach these two guys. When troubleshooting, you find that you can successfully reach the servers from R2, which is this guy. What is the most likely reason that the other users are expecting connection failure? Okay, so R2 is able to reach these guys, so definitely there is no routing problems. Okay, since R2 can reach this broadcast domain, and these guys, then we have no problem routing. Interfaces are all up, so either it's a layer 1 issue between the switch and these guys, maybe the ports are not accessed to this one, maybe it's on VLAN 1, but maybe the gateway is not assigned to the PCs, maybe they do not have a gateway. So let's see the possibilities. A, interface ports are shut down on the remote servers. No, because R2 did reach them correctly, so no ports down from R2 and up and beyond, okay, to the right. B, the DHCP address pool has been exhausted, so you mean that the PCs do not have IP address? Well, actually it seems, according to the exhibit, that refer to the exhibit, that there is IP address for the computers. C, the IP helper address command is missing, since it's already having an IP address, so we are not complaining about no problem about, I'm sorry, there is no problem with IP addresses. I'm sorry. Okay, and D, VLSM, yeah, VLSM is misconfigured between the router interface and the DHCP pool. There is no VLSM in the CCNA. And VLSM was standing for VLAN, I believe. No. VLSM is not VPLS. I thought about VPLS. No. There is a VLSM. Let me just check again. What was VLSM standing for? Let's see if the official books do talk about such thing. Yeah, variable length subnet masking. Oh, okay, I'm sorry, I forgot chapter one. Okay, so it's talking about VLSM. Let's go back. There was VLSM is misconfigured between the router interface and the DHCP pool. Yeah, just 1 minute. 1 minute. Yeah, that will be definitely correct. Why? Because these two PCs are on the network of 10.120.26.130 and 100, so something, and the gateway says that it's 10. It should be 10.120 dot 1. No, no, no. Yeah, I got it. Okay, so let me inform you about the mistake, which is, you can see that this is says .1/25, so the entire network on the left of the router should be on 25. Okay, so the network should be 10.120.26.0/25. Okay, the dot one is the gateway, which is this router. That's correct. And starting from dot two up to /25 gives the increment of 128. So the broadcast will be 127. Okay, so the last valid IP address will be 126. So 10.120.26.126. This is the last valid IP address on this network, and we can see that this guy is having 130, so this one is from another network. And if these two have got the same IP address from the same pool, because it says that there is a DHCP pool, this means one thing, that the pool inside this router is configured as a /24. Why? Because these two computers received IP addresses from the same pool. One of them has received 130. So the pool is definitely not /25, because /25 ends with 127, and this PC just received 130. So the subnet mask of the DHCP pool inside R2 is bigger than 25. It might be 24, 23, and so on, because that's where the limits of the address range is bigger. So we can see that the interface of the router has /25. These guys do not have /25. It's either /24, 23, and up until /8. Okay, we have no idea, but we can know that there is a misconfig in the subnet mask between these PCs and the router, the interface of this router, which makes both of them in a separated broadcast domain than the router itself. So yes, VLSM is misconfigured, variable length subnet mask is misconfigured here, and that causes this problem of unreachability. Hope that was good. Okay. Question 129 says that, which of the following is the JSON encoding of a directory of a hash? We have talked about JSON a lot in chapter 7, and we have seen a practical lab and using EVNG. So which of these is a key value pair of JSON? The question means A, this one key value, which has a curly bracket enclosed with double quote because it's a string, a colon, okay, a value that's also a string, the value that's enclosed with a double quote, and finally the entire key value, the entire pair is enclosed with a curly bracket. This one is definitely correct for a JSON key value pair. B starts with incorrect type of brackets, so it's not acceptable. C has this symbol instead of a colon, so this one and the dot also are not accepted, so C is incorrect. And D has the standard crescent. I believe in the Arabic language we call it like, if we can translate it will be called like a crescent brackets. Okay, like a crescent this way, this crescent. This is a banana. Okay, crescent, whatever, this way. So this is these pairs are enclosed with a crescent brackets, make them unacceptable or incompatible with the JSON language. So this is a JSON key value pair and how it should look like. So A will be the correct answer. Okay, question 130 will be, sorry, which option best describes an API, which is the structured data that are discussed exchange between controller and a northbound, controller and a southbound, and so on. So a contract. Does it have signatures? Okay, a contract that describes how various components communicate and exchange data with each other. Might be. This is deep. Okay, let's see the others. B, an architectural style versus a protocol for designing applications. Is it style? Or we can call the architectural style actually should be called for the language that's building the software, like YAML or Ruby. The languages that do build Ansible, Puppet, and Chef, I believe B should be describing a software, not the API itself. No. C, a stateless client server model. No, we are heading to software management application software. No. Configuration management application. No. D, request a certain type of data by specifying the URL path that models the data. Certain type of data. It's about requesting. Yeah, because there is such thing between guys, but in APIs, because one will be asking for the updates, the other one will be replying, but not the API that's requesting. API actually the data that are being transported, the structured data that being transported, that are describing the components. So this is much more accurate for an API description, not D. I mostly believe, yeah, I'm mostly sure of that, yeah. So A would be much better than D for that. Definitely not B and C, but A. Okay. Which command verifies whether any IPv6 access list are configured? All the old um, commands of router that we have used in the entire course of like show IP route will show the routing table. Show EIGRP neighbors, or show, I'm sorry, show IP OSPF neighbors will show the neighbors of OSPF. Show IP OSPF database will show the database. Show IP access list will show you the access list configured. Show IP DHCP binding or database will show you everything. When it comes to IPv6, all the results of IPv6 will never be shown by using these commands. You will always need just to make a small modification for this command, which is whenever there is an IP syntax, just make it IPv6. So show IPv6 route, show IPv6 DHCP binding, snooping, database, show IPv6 OSPF neighbors. I believe it was, yeah, it was this way. So this is how it showed. So also show IPv6 access list. Okay, so whenever you see an IPv6 command, it's just the same IPv4 previous command, all command that we know, just add the v6 to the IP syntax. So show IPv6 access list will show you the access list configured for IPv6. Okay, so that would be C. 132. Which command can you enter to allow telnet to be supported in addition to SSH? A, transport input telnet and SSH. Yeah, because it's an addition to SSH, not only telnet. That's correct. Transport input telnet will enable only telnet. No transport input telnet, you are killing him. Privilege 15, this is for authorization and the privilege level of this guy, of the user that's accessing. This is not about the protocol of accessing, but about the privilege of it after it has gained access. Okay, so A will be correct for that. And we have used transport input SSH in a lab, in two labs in chapter 4 for the telnet and for SSH for switches and routers. Oh yeah, Cisco doing like the other guys right now, because for the first time ever I see a true and false question in Cisco's exams. I have seen that in Juniper's and Huawei, yes, a lot, like for 3 or 4 questions in Huawei's exam, 2 questions or 3 in Juniper's associate exams or even a specialist. I believe it was only in the associate JNCIA journals. So, okay, this will be very simple. So it's an information, it's either correct or not. What do you think? Okay, it will be one thing. So AAA stands for authentication, authorization, and accounting. Yeah, correct, true, that is true. B, that's it, as simple as that. Okay, so this is true because we have studied AAA in chapter 5. and we talked about it a bit in SDN, I believe so. No, yeah, I believe in chapter 6 also in the wireless. Maybe I've talked about it, but majorly in chapter 5. Okay, 134. This is a DND. An interface has been configured with the access list that's showing below. Which access list? Okay, these are two syntax from access list. On the basis of this access list, the results of this access list, drag each information on the left to the appropriate category on the right. So access list 107 says it's one thing, so it's extended, meaning source and destination. Deny TCP from this network because there is no host word here, and there is an IP with a wildcard mask. So this entire network of 207.16.12.0, and they have this wildcard mask to any destination. So these guys cannot reach any HTTP. There is a TCP equal HTTP, which is TCP 80. So whatever type of device in network 207.16.12.0, whatever device lies inside this network will not be able to reach any type of HTTP or browsing services from with any destination. So internet is almost dead with them. Okay, for those guys. And this second syntax will be, of course, permit IP any to allow those guys to have other services than the HTTP. So what's permitted and what's denied? Okay, so source 207.16.32.14, destination HTTP, is it permitted or denied? How do we know that 14 lies within this network or not? We have the wildcard mask. We need to make it a subnet mask to know how many IP address or the address range of this network. That will be, we have 207.16.12, and it's a public network. Okay, 0, this is their ID. The wildcard mask is 0.0.3.255, meaning that how can we convert the wildcard to a subnet mask? The old equation was to make 255 minus the quarter. 255 minus the quarter will give you that. So that will be, I believe it will be the same thing. Yeah, it will be also 255 minus the value of the part or the octet of the wildcard mask will give me a subnet mask. So 255 minus 0 will be 255. 255 minus 0 will be 255. 255 minus 3 will be 252. And 255 minus 255 will be 0. So this is definitely a correct and healthy subnet mask. So it's 255, 255, 252, meaning that it will be not slash 24. This will be slash 22. Yeah, because these are 8 ones and 8 ones 16, and these are 252, 253, 4, 5 are coming from 1 and 2. Yeah, so that will be slash 22. So this network will be slash 22. This network slash 22 comes before slash 23, which comes before slash 24. So since this slash gives me 254 IP, those guys are doubled, so almost 510 IP. These guys are even doubled than this one, so these guys will be 1,000 and something IP address. So since the network starts with .0, so their address range will be more than 1,000 valid IP address, and this will be an increment of 4 here because each octet here will be full after 250 such IP address. So this will be 207.16.12 all, 207.16.13, 207.16.14, 207.16.15. So all of these are under this subnet mask. Yep, so that will be almost everyone. So from 207 16 12 something up to 207 16 12 13 14 15 something, all of these guys are under this network. Okay, so dot 32 16 dot 32 dot 14, so this guy is way beyond 15. This one will be I'm sorry, this one is not included in this deny TCP 80. DCP, I'm sorry, TCP, HTTP, so this one will be permitted. It's not in the deny list, it's not included. If the source was 207.16.15 something, and the destination was port 23, the destination was 23 telnet, TCP 23 telnet, not HTTP. So it's not included in the deny something. So this one is also permitted, okay? Because this one lies within this network, but this network is only denied for HTTP, and 23 is TCP, okay? So it's also permitted. It can't pass through. If the source was 207.16.14 something from this range, yes, and the destination was 80, so TCP 80 is the same as HTTP, so you are denied because you are mentioned here in the access list. Good. If the source was 207.16.13 something, so it's from this network, and the destination was HTTP, so you are included. I'm sorry, you are in the blacklist. Go ahead, you are denied. And the last one should be here because the source is some guy from 16, so it's not mentioned, and the destination is 53, so 53 will be mostly UDP 53 or even TCP 53. That will be DNS, so you are permitted to pass through. Okay, so we have two guys from this range. They are denied for HTTP, and other services are permitted, other networks and address ranges and prefixes are also permitted. Okay, so that will be question 134. I'm enjoying that actually because we are offline and we are chatting here, but in the exam you have time, so you might not join it, you might join it. It depends on the time remaining, but I hope that you will join it. You need to love this. Okay, so that will be question 135. What will happen if you configure the logging trap debug command on a router? Logging trap debug, you remember on syslog it was the most simplest type of messages that will show by default as some obvious messages and events that are happening. So it will be like showing forever for everything. Whenever an OSPF sends a hello packet to its neighbor, whenever an OSPF receives a hello packet, it will show things that you do not want to know because these are something behind the scenes. So this is the debug. Okay, logging trap debug, meaning that keep showing me the debug messages of the detailed behind the scenes messages and logs for what's happening while a logging session is established, authenticated and authorized and such. Okay, so what's happening then? It's either A, it causes the router to send messages with lower civility levels to the server. Yeah, because it's logging trap debug, so it will be generated. Mostly this one is correct. B, it causes the router to send all messages with severity level warnings. No. Critical emergency. No, we are talking about debug. Just chill a bit. C, it causes the router to send all messages to the syslog server. We have only mentioned debug. D, it causes the router to stop sending all messages to the syslog router. No, actually debug will be sent. Yes, so it causes the router to send messages with the lower severity levels, which are debug, to the syslog server. A will be correct. Okay, that will be 135. Mhm. 136. Which Cisco IOS command will indicate that interface gigabit Ethernet 00 is configured via DHCP? Show interface gigabit Ethernet 00 will show you the IP address it was statically assigned or DHCP, and show IP interface brief and heading to gigabit Ethernet 00, you will see that it was assigned either automatic manually or by DHCP issue. So there's two commands that we can see that, or even show run in config. You will see the configuration inside the hierarchy of gigabit Ethernet 00. You will see IP address DHCP. This command will be there. So I have multiple ways. Let's see the possibilities. A, show IP interface gigabit 00 DHCP. No, because it should be only show IP interface gigabit Ethernet 00. This will be enough. B, show IP interface gigabit. No. This command is incorrect. It should be show interface gigabit Ethernet 00. This one is, yeah, this one is mostly correct. Show IP interface DHCP. Will that be shown? I need a lab. Okay, show IP interface gigabit. This is the same command of A. or show IP interface gigabit Ethernet 00 brief. There is no such command, and there is no such command. Suspecting show interface gigabit Ethernet 00 will show you that. Okay, we will need a lab, so allow me for 1 minute just to make sure of that. Okay, I will need the pack tracer. If I knew, then I would enable the pack tracer or run it even before we start. Okay, so let's log in. 1 minute. I'll need to log in. Okay, so we have, I need a router. I need another router just from the perspective of connection. I need a connection between them. Let's zoom in a bit, show the guys here, and let's configure this one just as an example. So that will be no enable configure terminal interface FA, the same config, fast system 00 IP address DHCP. It will not be manual, no shutdown, end. So let's see which command will verify that this interface is configured for DHCP IP assigning, not statically. So show interface fast Ethernet 00. Okay, the informations are fast Ethernet 00. Line protocol is down. I don't care. The address, this is a physical address. No, it's not showing. Maybe because it did not get an IP address or not. What was the other possibilities? Okay, other possibilities were is there a command which I know that's not there, but is there a command show IP interface like fast Ethernet 00 a question mark, so there is no DHCP or brief, definitely. But there is such command. If I hit it enter, there will be yeah, I think we will not get a correct answer here because I'm going to show IP interface DHCP. There's such command. There is no such command. Show IP interface, it either dialer, brief. Okay, because if I hit it brief here, this will be more than good because this will show me that fast Ethernet 00 is configured for DHCP. So this is one of the commands that I would rely on. This is number one. Number two, show run. Show run will show me. Show run fast Ethernet 01. I'm sorry, it was 00. No IP address. Okay, that's because it did not get. How about we configure R2 as a DHCP? Okay. CLI. Do you have time for that? Because right now this is studying, this is not the exam itself, so we have time. Interface fast Ethernet 00, no shutdown. And let's assign a static IP address for this interface and makes it give dynamic IP addresses for this the other guy. IP address will be 10.10.10.1/24. Exit from the interface. IP DHCP pool triple I. The network would be 10.10.10.0/24, and the IP default, the default router, this guy will not use it, but for other PCs in the future, whatever, .1, exit. Never forget to exclude the 10.10.10.1 to avoid duplication, and okay, so go back again here. Yes, now it's up, but let's see, show IP interface brief. It's still not assigned. but still not assigned. Still no IP address for fast Ethernet 00. Actually, it should have received so far. There is yes, a DHCP message saying an assigned message. Interface fast Ethernet 00 has assigned the DHCP address 10.10.10.2 with the mask of 24 from hostname router 0. Thanks a lot. So this is the IP address. Now we go back again to the commands that were suggested from the question. Let's see which one will show that this one is configured, because show IP interface brief is not here. We can see that. Show run is not here. We can see that also. This is R1. I'm sorry. This is. Let's go back to R0. Yep, this is R0. So let's try our luck. We know that A and E are not possible because there's no such command already of show IP interface fast Ethernet or gigabit Ethernet, then DHCP, all of that. This is not possible. So again, show interface fast Ethernet 00. Okay, now the IP is showing. It's up, line protocol is up, the hardware, the MAC address, the internet address, which is the IP, is there. Anything regarding DHCP? Unfortunately not. I'm sorry. My hope is with C, which is show IP interface DHCP. Show IP interface. There is no show IP interface. Well, one of the guys were there actually. So this command is not show IP interface, not, I'm sorry, show interface, show IP interface DHCP. So there is no show IP interface DHCP. No show IP interface DHCP. Oh. Okay, show IP interface fast Ethernet 00 slash something. Address determined by DHCP. So show IP interface, the name of the interface will be good. Yes, thank you. Show IP interface, the name of the interface will show you that this interface is up and up. This IP address, the subnet mask, sorry, the broadcast ID of its network, and address determined by DHCP. So D will be correct. Finally, D show IP interface, the name of the interface will show you that it's assigned via DHCP. So that would be D. Go ahead, 136. Now 137. Which statement about the nature of NAT, network address translation overload? So that would be NAT or PAT. PAT. Yep. A, it applies a one-to-many relation to internal address. No, one-to-many to external address, because the one is the external. B, applies one-to-one. No, overload is not one-to-one. That would be static. Applies many-to-many. Many to many would be the dynamic NAT, the guy that uses pools of both sides. I access this with a pool. D, can be configured only on gigabit Ethernet interface. And no. So then A would be correct, because it says apply one-to-many. I agree. Relation to internal IP. Oh, I'm sorry, internal IP addresses. So the one-to-many relation will be applied to those internal multiple IP address, like 65,000 internal IP address will have the relation of one-to-many. They are the many. They will be configured to one public IP address. So I will definitely choose A, because these guys are out of this universe. Okay, we are talking about another types. A. And D is catastrophe. Okay, 138. Which command is used to configure IPv6 static default route? Would that be zeros? No, it would not be zeros. It should be a colon colon. Okay, let me see 1 minute. OSPF was configured not by advertising network, but actually by assign advertising inside an interface. So IPv6 static route, I did use IPv6 static route and made a lab, but it was not for a static default route, because static default route differs. A IPv6 route colon colon slash 0 and then the next hop. This is about the 5. IPv6 route default interface next hop. IPv6 route, this is an IPv4. IP route, this is an IPv4. So it's either A or B, but what's with the 5? You know what? I have a packet tracer running. Okay, let me make use of it. Okay, so configure IPv6 unicast routing and IPv6 static route. What? No, static route. I'm sorry, IPv6 route. The possibilities will be IPv6 route. Okay, so route. Let's make it a colon /0, and then I can specify a next hop, which will be a name of an interface. So what's with the possibilities? They were colon interface next hop or IPv6 route default. Is there something called IPv6 route default? IPv6 route. No, there is no default, so I must type in colon /0, and then I must specify the next hop. So this is routing everything for the next hop, which will be a name of an interface. Okay, so let's make it like fast Ethernet 00, and then I can make an administrative distance like of 5. So it will be floating IPv6 static route. Good, so A will be correct because it's an interface, and then next hop with a floating static route of with an modified AD administrative distance for the for a floating IPv6. That will be correct because this is incorrect and these guys are for IPv4. So A will be correct as you saw with me. 139 would be a lot of talking. Okay. What A? Which statement about static and dynamic routes are true? So this will be a comparison, static versus dynamic, and each quote should contain a description for static and dynamic. A says, dynamic routes are manually configured by a network admin, yes, while static routes are automatically learned and adjusted by a routing protocol. It says about not routing protocol, the routes. The dynamic routes are manually configured. Dynamic routes are manually configured by a network. No, static routes are manually configured. When you configure that to reach this destination, go to this next hop, just like we have saw in the previous question. So static routes are manually configured. Dynamic routes are automatically learned by the protocol itself. So this is opposite. Okay, this is reversed. Static routes are manually configured by the admin, while dynamic routes are automatically learned. Yes, that is correct. Let's see the other two. Static routes tell the other router how to forward packets to network that are not directly connected, while dynamic routes tell the router how to forward packets to network that are directly connected. Well, both of them do the same function there. The dynamic routes tell the router how to forward packets to the network that are not correct, and this is the opposite. Both of them are incorrect. So B would be the definition of static versus the definition of dynamic. 140. What is the purpose of show IP OSPF interface command? Show IP OSPF interface. Show IP OSPF interface. This will show you which interfaces are included or have their networks advertised by OSPF. A routing protocol. Okay, A, displaying OSPF related interface information, maybe. B, displaying general information about OSPF routing process, no. C, displaying OSPF neighbor information on a per interface basis, mostly. D, displaying OSPF neighbor information on a per interface type basis. What's the difference here? Interface type. Interface type. No. So is OSPF related interface information or neighbor information? I'm confused because both of them like almost similar, because one of them will be included in the other, but maybe there is a cost configured for manipulating inside this interface. And since it's not showing the neighbor, yeah, it will not show the neighbor. Actually, neighbor will not be showing this interface. It will show you the network of the advertised OSPF advertised networks here. So this will be A. Yeah, I will go with A. That will be good. Okay, so displaying OSPF related interface information. A would be good. 141. How can the CDP protocol be used? It allows a switch to discover the devices that are connected to its ports. Yeah. B. To determine the hardware platform of the device. Of the next device. Yes, that's correct. But of me, no. Did not mention something about other guys. Okay. C. To determine the IP address of the connected Cisco devices. Yeah. Because if you hit show CDP neighbor detail, it will show you the details, specific details, MAC address and IP address of your neighbors. So this will be shown, and you can telnet them or SSH them through this IP address. Try it; it will work. Yeah, so this is correct. D, all of the above. Okay, if you are talking about determining the hardware platform of the device, the neighboring device, then it's definitely correct. This is what's showing in the CDP command. So D, all of the above, I will go with all of the above. Okay, because all of them are correct, and such questions do exist in the exam. So yeah, that would be D, all of the above. Okay, 142. How does spanning tree prevent forwarding loops at OSI layer 2? So you know that spanning tree is about to prevent the loop that happens this way by disabling one of the interface and making it as an alternative interface. So A would be time to live TTL. No, this is for layer 3 loops. Layer 3 loops are prevented by TTL. B, MAC address forwarding. MAC addresses will not be forwarded through this blocked interface. Mostly not. C, collision avoidance. No, 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 no. D, port blocking. This is what's happening. This port will be blocked and thus layer 2 loops will not occur. So that will be D. If it was a layer 3, like it say, like, how does routing protocols prevent forwarding loops at OSI layer 3? Then you will choose TTL. This is very important. Okay. So that will be D. Okay, order the DHCP message types. This should be a piece of cake. Okay, order the DHCP message types as they would occur between a DHCP client and a server. This will be a discovery, an offer, a request please, and a reply, go on, and that's it. One of the guys suggested to make it discover, offer, request, acknowledge, or reply, or whatever you would like it, but let's make it A as acknowledgement. So that would be Dora. If you watch this series, I'm not interested in it, and I will not make my daughter watch it also. I don't like it. Okay, but you can make it as Dora. So it will be discover, offer, request, and it's called a pack here. So this will be DORP. Okay, but whatever. Okay, so that will be discover as the first one, an offer, then a request please, and finally I will receive my pack that's containing the information from the pool. Okay, so that will be DORA. 144, we are almost done at the end of the video. Yes, 3 or 4 questions are left. Which two statements about Ether channel technology are correct or true? Okay, A, Ether channel provides increased bandwidth, yes, by bundling existing fast Ethernet or gigabit Ethernet interfaces. Naam, yes, I'm sorry, into, I said naam, which is yes in Arabic. Okay, into a single Ether channel. That is definitely correct, sir. B, spanning tree does not block Ether channel links. No, they will be. Look, if you mean that, 1 minute, if you mean that I have a switches connected this way, and this is an ether channel, this is an ether channel, this is an ether channel, one of the ether channels must be blocked, because even if it was an ether channel, the storm will happen. So spanning tree will block an ether channel port if it was to cause a loop. Yes. Okay. B, you can configure multiple ether channels links between two switches using up to a limit of 16 physical port. 16 what totally, or per ether channel? Because per ether channel some softwares provide up to 8 ports, others are up to 16. Also Juniper and Huawei have up to 8 and up to 16. But you are saying multiple ether channel links, not aggregating or bundling multiple physical ports into one ether channel. This is tricky. Okay, let's see D. Ether channel does not allow load sharing or traffic sharing among the physical links within the ether channel. Why? Then what's the purpose of it? Yes, there will be load sharing, definitely. It does allow. E. Ether channel allows redundancy in case one or more links went down, then the others will keep operating. This will definitely be correct because if there was at least one physical port operating inside the ether channel, the ether channel will continue operating normally until the other ports are fixed or added again, like 2, 3, 4, up to 8 or 16. So A and E are extremely good. C is tricky. Let's leave it. B and D are incorrect. 145. Good. Which three statements? So I have F, so 6 answers, and I will have to choose 3, just like I told you before. Which 3 statements about MAC addresses are correct? Okay. A. To communicate with other devices on a network device must have a unique MAC. Yes. B. The MAC address is also referred to as the IP address. No, God. No. C. The MAC address of a device must be configured in the MAC addresses are not configured. MAC addresses are not to be configured. D. A MAC address contains two main components, the first of which identifies the manufacturer of hardware, which is issued by the organizational uniquely identifier. Yes. Yep. So this will be the first, and the second of which uniquely identifies the hardware. This is extremely correct. An example would be 0A colon 26 colon 38 colon D6 colon 65 colon 90. This is hexadecimal. This is written in 6 parts. Each part contains 2 nibbles. Between them is a column. So yes, MAC addresses can be written in 2 ways, either 4 digits .4.4 or 2 digits and then columns. So this is correct also. Yes. Or MAC address contains 2 main components. The first, which identifies the network on which the host resides. No, leave this one. This is an IP address that's containing the network part and the host part. Okay, so that will be A, D, and E, extremely correct, and just like we have talked about in chapter 2, the beginning of chapter 2. Okay, 146 will be which 3 statements about network characteristics are correct or true. Contains 3, and they have A, B, C, D, E. So F is missing. Yeah, F is missing. Let's hope that I will find 3 correct of these. A. Speed is a measure of the data rate in bits per second of a given link in the network. Yeah, like a kilobit per second. So it's bits. It's a kilobit. So it's a bit. Don't worry. It's 1024 bits. So it's still considered as a bit. So A is correct. B. Scalability. Scalability indicates how many nodes are currently on the network. No, actually indicates how easy it is to add nodes in the future. This is scalability. C. The logical topology is the arrangement of cables, devices, and end system. No, this is the physical topology. The logical topology, which is how the traffic is flowing through which cables or ports right now. So I wish D and E are correct. Availability is a measure of the probability that the network will be available for use when it's required. Yeah, we can consider that, yes. Reliability indicates the dependability of the components that make up the network, also correct. So I'm really thankful that D and E were correct and I did not need F. So I will go with A, D, and E. Maybe in the exam you will face only A, B, C, D, and E, and you'll have to choose 3, but I'm sure that there will be also an F. something like fixed in creating Cisco's questions. I've remembered something. In Huawei networks exams, there is ABCD always. ABCD, that's it. There's no E and F. So it's either choose one, choose two, choose three. There is a choose three question and has only ABCD. So just kick out the incorrect answer and apply the others. That's a trick, but don't use it. Do always think of it, just like we are doing right now in this video. Okay, and yep. Finally, one last question will be: which two statements about the purpose of the OSI are correct, are accurate? Choose 2 out of 4. Okay, so E is missing. A defines the network function that occur at each layer. Yes. B facilitates an understanding of how information travels through a network. Yeah. C changes in one layer do not impact another layer. No. Okay, layer 1 is about okay, layer 3, change in a layer 3 in packet. One of the IP address was changed, misconfigured on single device. Will that interrupt the TCP sessions between the two devices? Definitely, there will be no connection. So yes, it will cause some impact. Yes. D, ensure reliable data delivery through its layered approach. If it was a UDP, which is on OSI layer 4 transport layer, UDP is not reliable. So no. Yep. So that would be AB. Choose 2 and AB are very clear and accurate. That's it. That should be okay. So AB will be correct. Yep. That should be enough. Okay, so this is the end of these guys right now, of all of these questions. This is so far what I have received in April. It's 17th of April today, I believe. Not I believe, yeah, it's either 17th or 16th. No, it's still the end of 16th. It will be in 17th in a few minutes. And that's it. That's all you need to know right now. Okay, so you have 3 things so far for the English course: the complete course, 85 video, 29 hours, 6 videos here for preparation, and one last 38-minute video of how to book and take the exam from home, so you can get certified in April. That's it. Okay, good luck. I wish you all good luck, and I will wait for your questions and comments below the video. Thank you for watching, and I hope to see you in the upcoming video or videos later. Goodbye.